To start things off, Dr. Michael Shermer, who is the founder and editor of Skeptic magazine, which is sold around the world, largest circulation such magazine, and he also writes a column in Scientific American that I'm sure many, many of you read. So I'm going to call on Dr. Shermer to get things rolling here and introduce us to the idea of pseudoscience in his inimitable fashion. Dr. Shermer.
Thank you so much. And thank you to the Trottier Foundation for bringing me all the way out of here from California, where the governor is going to save our state. So welcome, and I just thought to tell you a little bit about what I do for a living. This is it, Skepticism. I'm the publisher of this magazine, Skeptic Magazine. It's the quarterly publication of the Skeptic Society. We investigate claims of the paranormal, pseudoscience, fringe groups, and cultic claims of all kinds between good science, pseudoscience, junk science, bad science, voodoo science, pathological science, non-science, and plain old nonsense. Thanks. I'd like to talk to you tonight about belief. All beliefs occur in the brain, of course. That's where everything happens. And I've been interested in this since I was in college. I would like to believe, so would you. In fact, we believe all sorts of things. The question is, what should we believe? So I started this study of the brain in the mid-1970s when I was in graduate school. To show you how long ago that was a complicated, sophisticated computer that ran our experiments in this Skinnerian lab. These are Hewlett-Packard programmable calculators. These are called pencils. I don't know if you've seen those before, and these are data sheets that are sort of the precursor to Excel spreadsheets. Anyway, and this was one of our pigeons that we trained to peck keys. You can peck the left key or the right key, and depending on the pattern, if he figures out the pattern, he gets rewarded with a little grain hopper that comes up there. But it turns out, as Skinner discovered in the 1950s, and we tested in our lab, if you randomly give the pigeon rewards, whatever he happened to be doing just before he got rewarded, he begins to repeat that. It's the very definition of a reinforcement is it causes the behavior to be repeated. But if he happened to be twirling around twice to the right, once to the left, and pecks the wall and then the key, that's what gets repeated, and that's called superstition or magical thinking. And if you think that's the product of being a bird brain, just go to Las Vegas and you'll see the effect there. So our brains are belief engines. That is, we're pattern-seeking primates. We connect the dots. A appears to be connected to B. Sometimes A is connected to B. Sometimes it's not. How can you tell the difference? Well, our brains are not very good at telling the difference. So this is called learning, associating A with B, whether it's Pavlov's dog, ring the bell, give him some food, he salivates, ring the bell, give him some food, he salivates, ring the bell, he salivates. He's associated A, the bell, with B, the food, and then he has a response. Or the rat pressing the bar, he associates moving closer to the bar with a reward, so he moves ever closer till he touches the bar. That's operant conditioning. These are all association learning. By the way, the little funny cartoon there, we'll press lever for food, that is how these experiments are done. You don't feed them, and then they're really motivated to run the experiment there for you. But I call this patternicity, that is the tendency to find meaningful patterns in both meaningful and meaningless noise. That is, we find those connected patterns A to B. And we make two kinds of errors when we find patterns, when we think we find patterns. A type 1 error is a false positive, believing a pattern is real when it isn't. And a type 2 error, or a false negative, is not believing a pattern is real when it is. That is, not recognizing a real pattern. So let's say, here's a thought experiment for you here. Hang on one second. Here's your thought experiment. You're a hominid on the plains of Africa 3.5 million years ago. Your name is Lucy. Thank you for those of you that know something about paleoanthropology. And you hear a rustle in the grass. Is it a dangerous predator, or is it just the wind? Your next decision could be the most important decision of your life. If you decide that the rustle in the grass is a dangerous predator, and it turns out it's just the wind, this is a fairly low-cost error. You've made a type 1 error. It's a false positive. You think it's this, but it's not. But no harm. You just become more vigilant, cautious, you move away, and no big deal. And you've all seen this on the fur, fin, and feather shows on the Nature Channel about how skittish most animals are. On the other hand, if you believe that the rustle in the grass is just the wind and it turns out it's a dangerous predator, your lunch you get a Darwin Award. You are being taken out of the gene pool before you've had a chance to reproduce, and therefore, I argue there is a natural selection for this process of just assuming that patterns are real. That is, patternicities occur whenever the cost of making a type 1 error is less than the cost of making a type 2 error. The problem is that assessing the difference between type 1 and type 2 errors is highly problematic, especially in the split-second life and death situation. So the default position is just to assume that all patterns are real. Just assume all rustles of the grass are dangerous predators and not the wind. Now, that's not foolproof. It's not a law of cognitive psychology. There are exceptions. But as a generalization, our brains tend to just assume everything we encounter is probably real. Every pattern is probably real. Every A we think is connected to B, we just assume it probably is. And therefore, there was a natural selection for the process of just assuming that all patterns are real. And we are the descendants of the most successful patternicity primates. So just lots of examples here of fun patterns that may or may not really be there that your brains will likely see. For example, what do you see here? What? Shout it out. A horse. Sure, a horse, of course, unless the horse is a frog. So simply by rotating the data, by rotating the picture, I'm reconfiguring the data of the model of what horses, or frogs, look like. And there he goes back to being a horse. So the way your brains work is they already have a model of what horses look like back there, all wired in. And then when you get conflicting data like this, it switches back and forth. How about this blob of black and white spotches? What do you see here? A few people see a cow. Yep, there it is, Bessie the cow. Now, by providing the red line, I'm giving you what's called a prime, a cognitive prime. I'm priming your brain to see the cow such that when I take it away, hopefully the cow should still pop in there. How about here? Yeah, this one's been around a bit too much to fool people. It's a Dalmatian dog, of course, and there he is. But if you didn't see it before and now I take the prime away, there it is again. So by giving you the prime, I'm telling your brain this is what you're supposed to see, and there it is with the conflicting data, your brain that has a model of it. How about here? It's planet Saturn. Yep. How about here? That's good. Jackson Pollock. Yes, nice. I haven't heard that one before. Yes, that's right. It's nothing. So if you think you see something here, see me after the lecture, because it turns out this is a test of psychopathology. No, just kidding. These last two images were used by a scientist at University of Texas, Austin, named Jennifer Whitson, who tests subjects under different environments in which they are feeling in self-control in the environment or feeling out of control in the environment. It's sort of a long, complicated thing I won't get into. The bottom line was that when people feel out of control, like they feel anxious or unsure, they're more likely to see something in this particular set of dots rather than those who are in control. And we know this is true, that there's a relationship between superstition and feeling in control of your environment. Malinowski's famous studies of the Trobriand Islanders, the fishermen, the further out to sea they went, where the environmental uncertainties increased, the levels of their superstition and the levels of their superstitious behaviors increased in a direct relationship. And you can see this in baseball players. This is the most famous superstitious baseball player in American baseball history, Wade Boggs, who as a fielder had very few superstitious behaviors compared to as a batter, where he had far more superstitious behaviors. Batters, at best, fail 7 out of 10 times. Fielders succeed typically 90-95% of the time. So the greater control you have, the less need for superstition. So that's one factor. Another factor was discovered by a psychologist named Susan Blackmore, who discovered that believers in ESP tend to see objects in this, for example, 70% greater image, more than skeptics of ESP. Okay, so the experiment is you give everybody in the room a little paper pencil test about how much you believe in ESP. You know, do you believe in psychics? Do you believe in astrology and tarot cards and all these sorts of things? And some people believe more than others. Those who tend to believe in ESP tended to see the object in here. By the way, do you see what the object is? How many of you see a fish? Yay, because that's what it is. It's a degraded image of a fish or something else. Anyway, so what Susan discovered was that if you tend to believe a lot of things, you're more likely to see patterns in random noise or degraded noise. Peter Bruegger, another psychologist, found that significantly more meaningful patterns were perceived in the right hemisphere via the left visual field than in the left hemisphere via the right visual field. These are like split brain type experiments where you can actually get an image to appear just on one side or the other. So this gives us a hint that perhaps patternicity, that is, maybe superstitions, occur more often in the right hemisphere than the left hemisphere. This is what Carl Sagan predicted in his Pulitzer Prize-winning book, The Dragons of Eden. There's no doubt that right hemisphere intuitive thinking may perceive patterns and connections too difficult for the left hemisphere. But it may also detect patterns where none exist. Skeptical and critical thinking is not a hallmark of the right hemisphere. So we tend to be champions of left hemispheric thinking, right? But this is also configured by other brain chemistry. More research, Peter Bruegger and his colleague Christine Moore gave 40 subjects L-DOPA. L-DOPA increases the levels of dopamine in your brain. It's typically used for Parkinson's disease patients. It caused both believers and skeptics, they gave them that test again, how much do you believe in ESP? It caused both believers and skeptics to identify scrambled faces and real and jumbled words as normal. That is, they found a relationship between dopamine in the brain and the tendency to see patterns, or what I call patternicity. But the effect was stronger for skeptics than believers. Why? I think it's because if you're already way up here on the belief level, you believe practically everything. You don't have far to go. So a little bump in dopamine doesn't really increase all that much. But if you're down here like me, you hardly believe any of these things, you have a long way to go, and the dopamine just has a greater range that it can have its effect. In fact, we know from neuroleptic drugs that are used to reduce or eliminate psychotic behavior like paranoias, delusions, hallucinations. What they do is they block receptors for dopamine. They are dopamine antagonists. So there may be some relationship between dopamine and psychosis. Too much dopamine, I mean. And amphetamines and cocaine, for example, are dopamine agonists. That is, they lead to euphoria, creativity, and rapid patternicity. So there's some balance to be found there in the signal-to-noise ratio between making type 1 and type 2 errors, such that perhaps the right amount of dopamine or right hemispheric thinking or whatever, this is still a fairly new field, to try to get the neuroscience of patternicity right. That is, you don't want to be, here's the problem, you don't want to be so skeptical that you miss all the interesting new revolutionary ideas that come along, but you don't want to be so open-minded that your brains fall out and you believe every wacky idea that comes down the pike. There's some pattern there, some balance of patternicity that's right. So my two favorite examples I use, the man on the left, Richard Feynman, Nobel Prize-winning physicist for figuring out the relationship of subatomic particles as they interact in a field called quantum electrodynamics. And this is his van, Feynman's van, in which he had these Feynman diagrams painted on the sides of his 1976 cargo van, which he drove around Pasadena, California, where I live. So there are famous stories of people that would see Feynman, the great Caltech Nobel laureate, driving around in his van. And the story goes, one day he was sitting there at Lake in Colorado, you know, where the Rose Parade goes by, and some guy rolls down in the window and says, "How come you have Feynman diagrams on your van?" And he says, "Because I'm Feynman." Anyway, so that's kind of funny. So he's rewarded for seeing a pattern, in this case the pattern of subatomic particles interacting, that no one else saw. And to this day, physicists still use Feynman diagrams. The man on the right also won a Nobel Prize in mathematics for his research on game theory and how games, people reach an equilibrium between following the rules or not following the rules, or defecting on relationships or cooperating on relationships. And this is called Nash equilibrium, and that's John Nash, who you all know through the feature film in which he was played by Russell Crowe as the schizophrenic. Schizophrenics see too many patterns that are not real. The voices of people that are talking about you, people right there in the audience that aren't even there. So the rub is finding the right balance between not believing any patterns and believing every single pattern that comes along. And that's That's the tool of science, to figure out which patterns are real and which are not. So it's a signal-to-noise ratio. For example, what pattern do you see in this image? How about in this one? Oh, come on, guys. Of course, you know these are Via Uno shoes or sandals. These have to be the most airbrushed feet I've ever seen. But of course, you already have a model in your brain that I'm tricking and playing with it by giving you only a limited amount of data to trigger the model in your brain to see what it is I want you to see. By the way, this is how all magicians work. They are way ahead of the cognitive and neuroscientists on this. They know how to trick your brain by priming you a certain way. So for example, with conflicting data, but because we're all environmentally conscious, we all care about lights and lamps and things like that because we don't want to burn too much energy, so you naturally see a lamp here. Often what you're thinking about determines what you see in the random pattern of shadows. And so, of course, again, because we're all environmentally sensitive here, we all see the dolphins, right? You see there's a dolphin there. And there, that's a dolphin. That's a little happy-faced dolphin. There's a dolphin. That's a dolphin. This is a dolphin here. That's a dolphin tail, guys. There's a dolphin. This is the famous, the impossible crate illusion. Again, we have models in our brain between our retinas and all the way back to the visual cortex in the back of your brain of what boards and angles look like from back to front. And they're not supposed to flip back and forth and boards bend around each other like this. But of course, I hear you say, all right, Shermer, but it's easy to trick the brain in 2D. That's flatland, all right? Here's the impossible crate illusion in 3D by my late friend Jerry Andrus, the great magician who specialized in building three-dimensional illusions from famous 2D illusions in psych textbooks. Can you see how it's done? Camera angle is everything. So the photographer is way off to Jerry's right, and so such that this board appears to overlap with this one overlaps with this one, this rope has a cable in it that holds it stiff, this one overlaps with this one, and so on. But even knowing how the trick is done, the illusion is so powerful, again, because our brains have already wired in models of what crates look like, angles look like, how boards interact with each other in a situation like that. This one was a big award-winning illusion discovered by scientists here at McGill University. Are any of the scientists here today, by the way? I was wondering if they would show up so I can thank them for this clever illusion. Turns out that the Leaning Tower of Pisa is not leaning at all. No, that's not it. I'm just kidding. It is leaning, but one of these looks like it's leaning more than the other one. Which one? The one on the right. Yeah, sure. These are the same photograph, just side by side. So the illusion is they explain it, that when you stand there, like say in New York City or downtown Montreal, and you look up, buildings tend to converge because of this convergence effect, like railroad ties or railroad tracks converging together. But in this case, what's happening is that the buildings are just parallel to one another because it's just the same. It's just a duplicated photograph. What I think is actually going on even more than that is that your retina and then ultimately your visual cortex is comparing this angle here with that angle. So rather than comparing this angle with that angle, by the way, I have another picture with the ruler so you can see I'm not cheating. They really are just the same photograph. So your eye is comparing this shallow angle with this steeper angle rather than with that one. And so that's what makes it look like it's leaning because of the angles you're comparing. And you can test that with this one. Again, same photograph side by side. You can see the people there. So your brain is comparing this angle with this one rather than comparing this one with that one. And that's what tricks the brain. Of course, certain things trigger automatic recognition software in our brains. In this particular case, facial recognition software. You only need 3 data points to trigger that pattern. Such like the famous face on Mars from 1976 that got the UFO community all a Twitter before there was such a thing. And so they wrote letters to NASA and JPL asking them, take a close-up photograph so we can see the Martians building the giant face on Mars and so on. So there it is. But if you squint, you can get the face to pop back out because by squinting, you're reducing the granularity of the data from fine grain to coarse grain and getting your facial recognition software to trigger. And it turns out there's faces all over the place. There's a happy face on Mars. Oh, this one's a good one. Hang on one second. I have to see if I can do this. One moment. This is well worth it if it'll work here. Okay. This is in Canada. This is another great facial recognition thing. This is so cool. It's the Indian head face illusion. It's a huge valley. And when you're in the valley, I've not been there, but there's people that take pictures inside there. You don't see it at all, of course, it's gigantic. But if I rotate it, this is also a nice effect. If I rotate it, for most people, including myself, it disappears because the mountains become a valley. Now it's sunk in. And for me, the face disappears. Does anybody still see the face? Oh, quite a few of you still. Okay. All right. Interesting. And then there it is back again. So if you want a link to that, just email me and I'll send you those coordinates there, how to get it. Okay. So back to that. I just wanted to share that with you because that's pretty cool. Okay. So there he is. Another one of my favorites, the nun bun, discovered by a Tennessee baker in 1996. Who had the bun laminated and on display. People could pay a couple bucks to see the nun bun until he got a cease and desist letter from Mother Teresa's lawyer. Charity only goes so far. Another one of my favorites is the Virgin Mary on a grilled cheese sandwich, which I actually got to hold. There she is, up close, sold for $28,500 only in America on eBay. But to me, does it really look like the Virgin Mary from the sort of medieval iconography? To me, it looks more like a sort of a 1950s Hollywood starlet. The Virgin Mary on the side of a building in Clearwater, Florida. Dawkins, myself, and Randy visited there on a Good Friday several years ago, where there's thousands of candles you could have lit. Because it was a Good Friday, a lot of people were there to be healed in their crutches and wheelchairs. There was a 2-story crucifix somebody had built there. So we walked around the back of the building. And it turns out Clearwater, Florida isn't. The water's not very clear. It's kind of mineralized. You could sort of see it in the grass there, the white. And it stains the windows. Every window was stained. And wherever there was a sprinkler head, like right here, and a palm tree, you get that sort of staining in that kind of almost human figure-like. In fact, I found one on the backside here in which they started to wipe it off, because I guess you can only have one miracle per building. But you can see the sprinkler head and where they cut the palm tree down there. So again, we have to ask ourselves whenever we encounter something anomalous or miraculous, what's more likely? Is it this or that? Is it really a miracle of Mary, or is it a miracle of Marge? I'm not Catholic, but I am a Simpsons fan, so when I saw it, I went, oh, looks like Marge Simpson. Of course, you recognize the President of the United States, but one of these looks slightly odder than the other one. Which one looks odd? The one on the left looks a little bit odd. Okay, I'm going to rotate it so the one on the left will now be on the right. Okay, so what's going on here is, again, there's 2 neural pathways in your facial recognition software, which is located in the fusiform gyrus in your temporal lobes just above your ears. And there's 2 cellular types there, one that fire very quickly, and those scan the general face. Facial recognition, it's a face, period. It's somebody I know. And then kicks in the slower firing ones that scans details, eyes, nose, cheeks, ear, eyebrows, so forth. And that's how that particular illusion works. Again, 2 pathways. This is why, for example, when you do a double take or triple take, like, I think I know you. I've seen you. Have I seen you before? Oh, So what you're doing there is you're collecting data so that the fusiform gyrus can check with old models in your brain from your memory. Is that somebody new or is that somebody old? It's like the déjà vu experience. You're driving across the country and you pass through some town you've never been and you have this feeling, God, I feel like I've been here before. That's because there's only so many ways to design a town, especially when you're going cross country. There's a corn silo on every one. There's a Denny's. There's and so every town has, they sort of similar, and that triggers that kind of double take. Recognition software kicks in, gives you a feeling of deja vu. Okay, back to our thought experiment. You're a hominid on the plains of Africa 3.5 million years ago. Your name is Lucy. You hear a rustle in the grass as dangerous predator, or is it just the wind? What's the difference between the wind and a dangerous predator? Well, the wind is inanimate. A dangerous predator is an intentional agent. Intentional agents are dangerous. Inanimate objects are not necessarily dangerous. So by intentional agent, I mean what I call agenticity, that is, the tendency to infuse patterns with meaning, intention, and agency, often invisible beings from the top down. I think agenticity, patternicity, and then coupled to it agenticity is the basis of our beliefs in souls, spirits, ghosts, gods, demons, angels, aliens, intelligent designers, government conspiracists, and all manner of invisible agents with power and intention are believed to haunt our world and control our lives. I think agenticity is the basis of animism and polytheism and monotheism. The belief in aliens. Just think about the narratives of everyone from science fiction writers to alien abductees to SETI scientists. The aliens are always super advanced beings, technologically advanced, scientifically advanced, morally advanced, because if they manage to get to where they are without nuking themselves or destroying their environment, they must have figured out, not just technologically and scientifically, but morally how to survive. So they are almost godlike figures. Intelligent designer is basically, it's just like a really more advanced J. Craig Ventnor and the Genome Project. Genetic engineers on high, coming on on high on down into our world, stirring the particles, somehow melding RNA into DNA, which could have happened naturally, but with the intelligent, again, our brains tend to see design in everything. We have vast experience of design, artificial design, stuff that we make. So naturally, when we see a natural design, we think there must be a natural designer. And until Darwin, we didn't have an explanation for that, which we now do. Also call this the God of the government or the intelligent designers. In government, we tend to think that somebody up there should do something. That people, almost all of us think they should do something about X, the economy, whatever. And the they is always the big power source up there, which is also the basis of conspiracy theories, that somehow there's these 12 men called the Illuminati, and they meet in London once a year to plot out the world domination and control of the economy so that it runs right. Well, you can see how well they've been doing the last few years. That is, we're uncomfortable with randomness, uncertainty, complexity. It's not much fun to think of the economy as this bottom-up, self-organized, big, messy thing that's really hard to control with 50 different variables. No, it's just these 12 people that meet, and they plot the whole thing out, the Bilderbergers, the Rothschilds, the Rockefellers, the Illuminati, and they're controlling the world. JFK is one of my favorite conspiracy theories. If you ever get a chance to go to Dallas, be sure to visit Dealey Plaza. On any given day of the year, you will find some of the JFK conspiracy theorists there. Here's one of them pointing out to me on the right where one of the assassins was located. In a manhole. Popped out, shot him, and popped back down like a video game. So there's a cognitive dissonance there between the size of the event and the size of the cause. Leader of the free world assassinated, Lee Harvey Oswald, nobody. It just doesn't feel right. Leader of the free world assassinated, must have been assassinated by the CIA, the FBI, the KGB, the Mafia, the Cubans, the Russians, and so on. You have to add it all up so they balance. Princess Diana. Cause of death, drunk driving, speeding, no seatbelts. How boring is that? That's so mundane that Princess Diana, she's a princess, has to be murdered, by the MI5 or the government or the royal family or something equal to her in status, right? Of course, some conspiracies are real. Lincoln was assassinated by a conspiracy. And so we just have to face the fact, what's the real conspiracy and what's a fake conspiracy? Maybe this goes a long way to explaining why California has a $500 billion debt. Okay, let's talk about what the cause of this is. I'm just going to finish up here with a couple of thoughts on dualism. We're natural-born dualists. That is, we tend to think that there are two things, not one, two things. Dualism, mind and brain, body and soul, body and spirit, brain and soul, whatever two you want to pick. There's material stuff and then immaterial stuff. This is why we can watch movies like Freaky Friday, where Jamie Lee Curtis and Lindsay Lohan switch bodies. But wait, who's doing the switching, the body or the whatever it is, the soul, right? See, a brain transplant is the one transplant where you want to be the donor, not the recipient. But we don't think of it that way. So when we watch movies like this, we get it. We get what they're thinking. Oh yeah, because they're going to the other body and somehow being planted in there. Well, we know that where some of these things are located, starting with Wilder Penfield's early 1960s temporal lobe stimulation. These are usually open brain surgeries for epileptic patients, for example, and you get their permission to wake them up after you carve open their head. And you have the brain open up there, and you poke around with electrodes, and you just ask them what's going on. And they'll tell you, and if you poke around in that big green blob there, temporal lobe, you can stimulate the feelings of deja vu, out-of-body experiences, trances and fugue states, feelings of being in the presence of others, hearing music, angelic voices, intense meaningfulness, talking to God, and so on. We can replicate near-death and out-of-body experiences, for example. If you touch that red dot on the temporal lobe, you can get somebody to feeling like they're floating above the body. This was an experiment published in 2002 in Nature. You just ratchet up the electricity, and she goes way up to the ceiling. You reel it back down, and she goes back down to her bed. Left leg, right arm, left arm, and so on. All controlled just by neurons firing. This guy, James Winter, he discovered another type of out-of-body experience. G-force loss of consciousness accelerates pilots until they pass out. It's part of their training. About 25% of them had an out-of-body experience. The whole thing floating above the body, the tunnel, the white light at the end of the tunnel, the whole thing. It's all right there in the brain. Or you can put on Michael Persinger's God helmet. Michael is in Laurentian University in Sudbury, Canada, and I went there to see if I could have an out-of-body experience, and I did. It was kind of cool, actually, sort of fun. Drug-free and legal. By bombarding your temporal lobes with electromagnetic waves. Okay, so wrapping all this up and bringing it back together, I want to tell you about the mother of all cognitive biases, the confirmation bias, the tendency to seek and find confirmatory evidence for one's beliefs and to ignore disconfirmatory evidence. You remember the hits and you forget the misses. If you think the Jews are running the world, then you read books like The International Jew by Henry Ford or The Protocols of the Learned Elders of Zion. These are not old books. This is a table at a conference I was at just a year ago by the Holocaust deniers who are still around. Or you can go to more recent ones with 9/11 and read all the literature. So you filter out the stuff that feeds what you want to believe and you just ignore all the rest. Thank you so much. All right.